Genetic Inheritance by Riley Cox. Starting with Mendelian genetics, which brings us to our first slide. Mendelian patterns of inheritance. This photo shows the pea plant, which is one of Gregor Mendel's first big discoveries. You may be asking, what is Mendelian inheritance? Well, it is a way that traits and genes can be passed down from parent to child, where their offspring will inherit half of the types of the traits from the parents. This means that some of the traits and alleles will come from the mom, and some will come from the dad. Complete dominance is one big vocabulary word many people learn. This occurs when one parent has their dominant gene completely mask over the gene of the other parent. This means that the offspring will only show one gene of the mom, but the dad's gene will be hidden under, completely masked. And this image is from drlib.info. The next vocab word is Mendel's law of segregation, which is his first law of 3. This law explains that alleles will segregate or separate into different gametes. The next law is the law of independent assortment, and it states that different alleles that come from genes are sorted randomly into gametes. It also states that random assortment of one allele does not affect another. This photo is by Khan Academy. So in this simple Mendelian genetics problem, we will be crossing a male rabbit with the genotype B, lowercase e, and a female rabbit with the genotype b, E, lowercase e. So you're probably trying to figure out, well, what do all these B's and E's mean? So the homozygous dominant, B, would represent black hair for the rabbit. The heterozygous for that would be B, lowercase b, and that would also be black hair. Up next would be the homozygous recessive. This would be lowercase b, which would represent brown hair, a bit different than black. Up next are the E's. The homozygous dominant would be E, and it represents long ears. Up next is the heterozygous, E, lowercase e, which also represents long ears. And finally, lowercase e, which represents floppy ears. So we can now go on to filling out the table by taking the parents' ratios and plugging them in. So it would look like this. B, lowercase e. And you'd repeat this through the top row. And on the bottom row, it changes a bit. It'd now be lowercase e, E, lowercase b, lowercase e, lowercase b, and lowercase b, lowercase e. I'm going to start by filling out the table and show you again once I'm done, just so you can get the hang of it, but not feel like you're watching it for too long. So I'm going to take the B from right here, and the B from right here, and same with the E's, and plug it in. So it would look like this. I can now continue to do this throughout the whole chart. So B down here, lowercase b, and 2 lowercase e's, just to show some variety. Alright, so now that I'm done with my entire chart of the genotypes, I filled it out. So now you're thinking, what do we do next? Well, we obviously want to figure out what are the ratios, such as how many rabbits have black hair and long ears, etc. So I'm going to highlight because that always helps me. So let's start with the B's. If you notice, as you start going through, you're noticing every single B, which represents hair, is black, and it's heterozygous. This is because on the top column, it's all B, and on the vertical column, it's all lowercase b. So when you mix, it has to give you one of each. But if you look at the E's, up here, all the E's are lowercase, but up here they vary from a E to a lowercase e, and so on. This means that the E's will come in 2 different forms, either heterozygous or homozygous recessive. I'm going to start with the heterozygous. This means E, lowercase e. I'm going to go through and highlight these, and if you notice, they're all in the same 2 columns, which makes it a bit easier. We're now going to go on to the homozygous recessive. These are in the 2nd and 4th horizontal columns. Once we've finished figuring these out, we can now take these highlights and easily figure out ratios out of 16. We can start with how many out of 16 have black hair and long ears. Well, we know that all 16 have black hair, so now we really just have to figure out how many of these have long ears. Well, long ears is heterozygous, and we know that 1, 2, 3, 4, 5, 6, 7, 8 all have long ears. So it would be 8 out of 16. Up next, let's figure out how many out of 16 also have black hair and floppy ears, the homozygous recessive. We know that's possible because that's the other highlight color. So we start counting. 1, 2, 3, 4, 5, 6, 7, 8 again. And we could keep going and ask about brown hair, but that's not really an option because none of them have brown hair. We know this because every single beat is heterozygous, so brown hair is not an option.